Good morning everyone. In our previous video, we realized that we could not sketch x squared minus 2x plus 2, okay, this one over here, because number one, there was no x-intercept at all, which means that we cannot find our midpoint or our turning point, and hence, how do we proceed from there? Okay, so let us move to the next page, where we'll be filling up this table. Okay, we're going to make some observations by plotting all these graphs over here. Okay, for this I'm going to use desmos.com. So if you're on your computer, please log to www.desmos.com. Alright, now we're going to use this to plot all the equations in the table. So starting off with y equals to x squared. This is the most basic curve that you can get. So I'm going to plot y equals to x squared. Now in order to get the superscript over here, you press shift 6. You see the symbol that looks like a carrot, right? Okay, so you press x, then shift 6, you'll get the carrot, and then you press 2. That's how you get the superscript over here, y equals to x squared. So you realize that y equals to x squared is a nice curve that passes through the origin over here. So the minimum point or the turning point is over here. It is 0, 0. Of course, it's a happy face because my a is 1, which is positive, right? So it's going to be a happy face passing through the origin. Why? Because when I sub in x is 0, I will get y is equals to 0. So over here, the curve must pass through the point 0, 0. And the line of symmetry is basically the y-axis. Okay, so coming back to this, the line of symmetry is the y-axis. And the equation of the y-axis is actually x equals to 0. This is the equation of the y-axis. Okay, so the turning point, as we found out just now, the point 0, 0, okay, the origin. So turning point is 0, 0, and that's also the minimum point. Okay, so the minimum point is the turning point, which is 0, 0. Okay, the x-intercept is, remember, when y equals to 0, right? So when I sub y equals to 0 here, when will x squared be equals to 0? That's right, only when x is equals to 0. So the x-intercept is 0, and the y-intercept is when x is 0. So when I sub in x 0 over here, y is also 0. So that's the first row filled up. Let's move on to the next graph. Y equals to x squared plus 2. So I'm just going to type y equal to x squared plus 2, and I observe that the curve just shifted up by 2 units. Okay, so it is still having this line of symmetry, which is the y-axis, but the minimum point has now gone up to 0, 2 over here. Okay, so at this point you realize that this graph does not even cut the x-axis, it only cuts the y-axis at 0, 2. Okay, which is also the minimum point. So the line of symmetry is still the y-axis, which is x equals to 0. The turning point just now was at 0, 2, which is also the minimum point, right? The x-intercept, there was actually nothing. There was no x-intercept at all, because when you sub in y is 0 here, x squared will be equals to, let me just do it at the side. X squared will be equals to negative 2, which cannot be solved, right? When you take square root on both sides, you cannot take square root of a negative number. So basically there's no solution. No solution means that the graph does not even cut the x-axis. So there is no x-intercept, but there was a y-intercept, and the y-intercept is 2. Okay? Alright. Moving on to the next graph, y equals to x minus 3 whole thing squared plus 2. So let's type that. Don't forget the brackets. Y equal to x minus 3 whole thing squared plus 2. Nice. Now the graph has shifted to the right by 3 units. Do you see that? Okay. And the minimum point over here is at 3, 2. Do I see any x-intercepts? Absolutely not. The graph does not even cut the x-axis, right? So there are no x-intercepts, but there is a y-intercept. And where is that y-intercept? It's over here at 0, 11. So the 2 points that are of interest from this graph are the y-intercept at 11 and the turning point at 3, 2. Okay, so let's just fill that up. Turning point is 3, 2, which is the minimum point, right? There was absolutely no x-intercepts and the y-intercept was at 11. The line of symmetry, if you go back to the graph, this is the line of symmetry passing through the turning point. So this line over here is actually the x equals to 3 line, the vertical line passing through the minimum point. So this is the x equals to 3 line. Alright, now just to highlight how this 11 came about, let's use blue. Okay, remember the y-intercept is when x is 0, the x-intercept is when y is 0. Okay, so if I want to find the y-intercept just from the equation, I can just simply sub in x equals to 0. I will get y equals to 0 minus 3 whole thing square plus 2. Okay, negative 3 the whole thing square is 9, positive 9, and you have a plus 2, so it becomes 11. That is how this 11 over here came about, okay, the y-intercept. Similarly, for the previous part, you also sub in x equals to 0, you will get y equals to 2. That one is easy. And the first part was when x is 0, y is 0. Okay, so this is how you get the y-intercept from the equation directly. You don't even need to plot using decimals. And anyway, during exams, you have no decimals. Okay, moving on to the next equation, y equals to x plus 5 whole thing square minus 4. Y equals to x plus 5 whole thing square minus 4. Is that what I want? Yes. Okay, so you see this graph over here. Ooh, now it has 2 x-intercepts, a turning point, and a y-intercept. Okay, if you want to find out what are all these points, right, you just simply click on them on the graph and then you will see all these dots that come out. You click on the dots, you will see the points. Very nice. Okay, so the 2 x-intercepts are at negative 7 and negative 3. Let's fill that up. Negative 7 and negative 3. The y-intercept is at 21. The minimum point is at negative 5, negative 4. Which is also the turning point, right? Okay, these two are the same. And the line of symmetry, of course, is the line passing through this minimum point, which is x equals to negative 5. So that is my line of symmetry. Okay. Now why are there 2 x-intercepts in this case? Because this equation can be solved. When I equate y to be 0 and I solve for x, I will actually realize that I get these two solutions, negative 7 and negative 3. Okay, let me just do that for you. Oh my god. Erase. I need some space. Okay, how to get the 2 x-intercepts? I'm going to equate the y to 0. Okay, and then plus 4 on both sides, take square root on both sides, so x plus 5 equals to plus or minus 2, and then x is equals to negative 5 plus 2, which is negative 3, or negative 5 minus 2, which is negative 7. So that's how they got these two values over here, negative 7 and negative 3. Okay, remember what we learned in the previous videos. So that's how you get the x-intercepts. How do I get the y-intercept? I just explained to you. You sub in x equals to 0. So this will become 25, right? 5 squared is 25. Minus 4, you get 21. That's how they got the 21 over here. Okay, so we've already done until this step. We've plotted 1, 2, 3, 4 graphs. Now let us come up with some observations. Okay, Okay, let's start with the x-intercept and the y-intercept first. Basically, every time you want to find the x-intercept, you would just sub in y equals to 0 and solve for x. Okay, so you still need to do some working, right? So you just sub y equals to 0 and find x. Okay, find the values of x. And for the y-intercept, basically you sub in x equals to 0. So when I sub in x equals to 0 into the general form here, I will get negative h whole thing square plus k. That's my value of the y-intercept. So negative h whole thing square plus k is my y-intercept. Okay, now the most important thing from this completed square form, right? This is the completed square form. The most important thing that we can find from this easily is the turning point or the maximum point. Now I want you to observe what we did for the previous two graphs. If you look at y equals to x minus 3 whole thing square plus 2, your turning point was actually 3, 2. Okay, which is the same as the minimum point over here. As for y equals to x plus 5 whole thing square minus 4, your turning point was negative 5, negative 4. Do you see a pattern? Okay, basically every time you want to find the turning point from the completed square form, the x value will be the value that makes the entire bracket here 0. Okay, and the y value is just the number over here. So for example, in this equation here, right, what value of x will make this bracket 0? X must be equals to 3. That is why the x value of the turning point is 3. What about the y value? You just look at the number here. This number here, together with the sign of course, will give you the y value of the turning point. So you get 3, 2 immediately from the completed square form. What about this equation here? In y equals to x plus 5 whole thing square minus 4, what value of x would make this bracket 0? X should be negative 5. So the x value of the turning point is negative 5. What about the y value? It is this negative 4 over here, the number over here, right? That is the y value of the turning point. So immediately when I look at the equation of the form y equals to x plus 5 whole thing square minus 4, this is in the completed square form, right? I will immediately be able to say, oh, my turning point is negative 5, negative 4.